2.5. How much do you get when you do that? Remember, you have calculators. You're allowed to use calculators in the state test. So therefore, using the calculator is a great advantage for you. Immediately when we divide y over x, we obtain 3 for the first round. Let's do the next one. 10.5 divided by 3.5. Oh, we get the same value. We get 3. But remember, 2 can be a lucky charm, right? So we need to keep going, and we need to ensure that we divide all of them to verify. We also get 3. And the last one, we also get 3. So we notice that our slope right here, right, is 3. We do have a constant of proportionality. Another name that we have, because these names are not here, correct? Now, here is another name which means exactly the same thing. It's rate of change. Do we have a rate of change? And if we do have one, it's a constant, right? It's a constant. So we need to confirm this information. Is the rate of change constant? Is this number changing or is the same? That's what the question is asking. If it is constant, it means that it's not changing, it's exactly the same. A, the function is nonlinear because the y-intercept is 0. Well, we don't know actually what the y-intercept is based on this table. We can find out, but we don't know for sure. Now, I know that this function, this is not truth. This is linear because we have a constant of proportionality. We have a rate of change, which is the same. So you cannot tell me this is not accurate. This is actually linear. The function is linear. Okay, we headed in the right direction. The function is linear because the rate of change is constant. Oh, we verify our answer. This is correct. This is our answer, B. Let's move on immediately to our next problem. Here we have problem number 34. Here, this problem is a bit tricky, and there are many ways to do it. I will do it using tracing paper, so that way it's faster, easier, and for you easier to understand as well. So I will be drawing this figure right here. I will be drawing this figure right here in my tracing paper. I have a ruler right here ready. So let's get started, right? This is my original figure. Let me make points in my vertices, right? And this is my line. Now I just have to connect these lines to these vertices, and I will have the original figure, right? I will have the original. Because this is what I'm rotating. I'm rotating F, G, H, J. This is what I'm rotating, right? It says that it is rotated. It says that it is rotated. It is rotated around the origin. So the first thing that I do is to draw it, right? Use my ruler, use my tracing paper, and draw it immediately. That's the first step that I do because that's the figure that I will be rotating. I have my figure here that I already draw. You can see it matches perfectly fine. Then we label it. Remember, this is H, this is G, this is J, and this is F. Now that I have my figure, it says that I need to rotate about what? About the origin. The origin, it's right here, remember? Is this point in the center. This is the origin. So all I have to do is to simply place my figure here, hold it with my pencil, right? Hold it with my pencil, and rotate it about the origin from this one to the other one, right? So look at this. When I rotate it, it fits perfectly into our new figure. It fits perfectly into our new figure. So you see, this is H and this is J. Here is J prime, H prime. Right? This is G prime, and this is the last point that we have, which is F. And therefore, it's going to be F prime. Good. It's been rotated. Now, which statement is truth, right? Which statement is truth? It says here that two sides are equal, right? Which two sides are equal? F and G. This is F and G, right? It's telling me F and G is equal to F prime, J prime. Do you agree with that statement? That when I rotate this figure, this side becomes this side? No, this is not correct. Because F, G will become F prime, G prime. This side is equivalent to this side. So we can use these dashed lines, right? To indicate that this is equal to this. So that's not true. The first statement is not actually truth. Now let's check at the second statement. FJ, or JF. JF is the same as H prime, J prime. I don't think so either, because when I rotated this figure, let me show you again. When I rotated this figure, J and F, and I rotated J and F, it was right here, is supposed to be F prime, G prime. So it does not become H prime, J prime. That's false. Now, the next one is GH. GH, right? GH. Right? GH is the same as H prime, G prime. Let's take a look at this real quick. Right? Let's take a look real quick. This side, let me rotate it. This side is the same as this. Oh, you see it? Is this the same as this? Well, it seems to me that it's exactly the same because I rotated this piece right here. This side length is exactly this side length right here. They measured exactly the same. It was simply rotated from one position to the other, and therefore our answer is C. Now let me give you a little tip, a little hint for you to remember when you see these kind of problems or these kind of questions. Because I don't want you to memorize the answer to this particular problem. I want you to fully understand what is happening. The only answer where I have the same sides or the same letters being used is C. You notice that? This is FG, but this is FJ, right? F prime, J prime. This is JF, but this is HJ. Look at this one. Look at C. GH and H prime, G prime. Isn't that the same? They are, because I can also rewrite this and write that HG and HG and H prime, G prime are the same. You see, this is exactly the same side length. I can also write it another way. I can write HG, right? Line segment HG and G prime, H prime are also the same. So you can write it in different order as long as they are the same letters, so the same side. Because this side right here and this is the same. It doesn't matter if you say G, H, or HG. This is the same as H prime, G prime, right? This is the same as this. It doesn't matter in which position you place it. It will always be the same. All right, let's move on now. We have problem now 35. This is a very interesting problem. I like these kind of problems because they're very visual, and you will be able to see what is happening, what's going on. So we have a large cane right here, and we have another small cane. And as you can notice, we have cylinders, right? These are cylinder canes. So what do we notice about these cylinder canes? That one is bigger than the other, right? Large and small. What is the question asking me? What is the difference between the two volumes? Oh, interesting. The difference between the two volumes. So what is the difference of this versus this, right? What is the difference? How much more this one has than the other one? Now, you're going to be careful because it's asking me here in terms of pi. In terms of pi. So let's see how that looks like. First, we need to look into our formula. And our formula for the volume of a cylinder is given to us, right? This is a formula that is always given to us. And that formula is very straightforward. The formula to find the volume of a cylinder is simply, right? It's very simple. Is pi r square h, right? Times h. Pi r square h. That's the volume. That's the formula to find the volume of a cylinder. That's the formula to find the volume of a cylinder. Pi r square h. Whenever it says, right, that we need to find the answer in terms of pi, it means that pi will not be equal to 3.14, right? Do not change pi to 3.14. Don't do that. That's what they're telling you. They want the answers with pi, not with 3.14, right? They don't want numbers. They want the answer with pi. So let's look at this, right? Let's look at this real quick. You can solve it anyways. You can still use pi equal to 3.14, and you can still get the right answer, but it may be a bit confusing, right? I'll show it to you at the end. So let's get the volume of the first one. The volume of the first one is pi r squared. What is r? That's my radius right here. That's my radius, 3.5 times 3.5 squared times h. What is h? H is the height. In this case, the height is 10. There you go, times 10. So the volume for this particular cylinder will be then 3.5 square times 10, right? 3.5 square times 10, then times pi, which is 122.5 pi. 122.5 pi. Now here we're going to do the same process. Volume is equal to pi r squared h. H is 6, right? Times 6. However, this is a tricky problem here. You have to remember that the entire length, right, that the entire length of a circle, in this case this is a circle, or maybe the top of or the bottom of the cylinder, whichever way you want to see it, that this entire length right here is representing the diameter. This is the diameter. This is the diameter. And we don't need the diameter in reality. You can, but in this case, we don't need the diameter. We need the radius, right? We need the radius. So the diameter is double the radius pretty much, right? The diameter is 7, so we divide that by 2, and therefore we get the radius, right? So our radius is in reality 3.5, right? The diameter is double, right? So the radius is the diameter divided by 2, right? The diameter divided by 2. This is our radius right now. So we're going to use the same radius. Oh, interesting, 3.5 as well. So we do the math one more time, and we do 3.5 square times the height, which is 6, and we obtain the volume of 73.5 pi. 73.5 pi. That's our volume. Now we need to find the difference of these volumes, because that's what the question is asking me. The difference between the volumes, right? The difference between the volumes. So therefore, I have 122.5 pi minus 73.5 pi. And we will be able to obtain our answer immediately, which is 49 pi. 49 pi. If you do it this way, you will see the answer immediately as it is B, right? If you do it this way. If you convert pi, then you will get a little messy in here, which I will show you real quick. You have to do 122 times pi, right? So 122.5 times 3.14, and that will give you 384.65, which is okay. It's the same thing. And then you do the same thing for the other, for the smaller cylinder right here. You do the same thing, and you do the same multiplication, right? You multiply 73.5 times pi, and you will get 230.79. Therefore, now that we have this, we just find the difference of these two. And we do 384.65, right? 384.65 minus 230.79. When you do this, you will find out that this answer is not there, right? You will obtain 153.86, and you might be wondering, wait, but this answer is not here. This is not one of the answers. Oh, so what about if you take the answers and you convert them to numbers, just regular numbers without having pi? So you will have to multiply like 4 times pi, 49 times pi. So let's do it real quick. 49 times 3.14. If we do 49 times 3.14, 49 times 3.14, you will obtain 153.86, which is the same answer. You see, these answers are the same. So whichever way you do it still works, but they want you to do it in terms of pi, which is easier and faster. I strongly suggest you follow the instructions. All right, 36 now. 36 is a very easy problem. It's just an equation that you have to solve. And as you can see here, we need to use distributive property. Distributive property. 2 times 3x will give me 6x. 2 times 1 will give me 2. And that is equal to x plus 1 plus 5x. In this side right here, you notice that we can combine the like terms. CLT, combine the like terms, because I have two variables right here that I can put together. So in this side, nothing happens. I have 6x plus 2, and that is equal to 6x plus 1. Right now, we identify something interesting. We identify that this side of the equation is not the same as this side of the equation, because this is adding 2 and this is adding 1. Immediately, when you know that the sides are not equal, your answer will be that it has no solution, because this is not equal to each other. Now, sometimes it doesn't have to be equal to each other. Because the real problem right here is that we have the same amount of the variable, right? We have 6x here and we have 6x here. They will cancel each other. And this is the reason that since they cancel each other, we will get 2 equals 1, and that is not truth. So that's why we conclude that it has no solutions. It may be the case, right, that you have maybe 5x here or 3x and you can solve it. Therefore, you're going to have exactly one solution. Or if it is equal on both sides, say this is 2, then you will have infinite many solutions, right? If it is equal on both sides, infinite many solutions. If the variables cancel each other, then it has no solutions. And if you can solve it and actually get x equals to a number, right? X equal to something, then that means it has one solution. I just wanted to let you know those little tips so that you can fully understand the concept behind these problems. Let's move on now. We have problem number 37 right here on our screen. And this is a very interesting problem because this is a problem that you can easily do on your calculator. So you simply type in the calculator square root of 2, right? You type square root of 2 and you press enter to find out that the answer is 1.414, right? 1.414 and then 21 and a bunch of other decimals. But you can stop here. 1.414, 1.4. Now, let's make sense of these answers. Is my answer between 0.5 and 1? That is not true. My answer is not between that. My answer is 1.4. Is my answer between 1.5 and 2.0? A little too high because my answer is less than 1.5. So that's not truth. Is my answer between 1.0 and 1.5 but closer to 1.0? That's interesting. So my answer is definitely between 1.0 and 1.5, but I don't think it's closer to 1.0. I think it's closer to 1.5 because it's 1.4, right? So therefore, my answer is D. Immediately, number 38. Remember to pause the video in any time that you are not understanding or you need some clarification. You can play it back again. And also leave your comments with any doubts or suggestions that you may have. Here we have a set of points, right? We have a set of order pairs, right? And we need to understand if this is a function or not. If this set will make a function or not. I always like to do these beautiful drawings, right? These are called like diagrams, set diagrams. And that way you can visualize what is actually happening. This is pretty much X and this is pretty much Y, right? But we also have to keep in mind, always we have to keep in mind that in order for us to have a function, we need what? One input, and that input will give me how many? One output, one unique output, right? One input, one output. So there's some rules about this, right? But visualizing it, it's better for you to understand it. So this is my X value, this is my Y value. So I'm going to write -3. Remember, you don't write repetitions, right? So I'm going to write -3 here. I'm going to write 1. I'm going to write 4. I'm going to write -1. I'm going to write -2. I'm going to write 3. And then I have another -2 right here, right? I have a -2 and I have another -2. We do write repetitions. I'm sorry. We do write repetitions here. So we wrote it down. And then here in the other side, we have the other values, right? We have 3 here, 1, 2, -1, -1 again, 1, and 3. Now, what I like to do is to match them. Because when you match them, you are visually seeing what is happening. So the 3 goes with this one. The 1 goes with the 1. The 4 goes with the 2. The -1 goes with the -1. The -2 goes with the -1. Okay. And the 3 goes with the 1. And the 2 goes with the 3. If you do it this way, you might see like, oh, no problem is happening. Everything is good. One input, one output. However, here's the catch. Here is the catch. We cannot have a repetition in the input. We cannot have a repetition in the input. So if we were to rewrite this again and do it without a repetition, you will see the problem. And then here we don't have repetitions either, so we can visualize it even better. So -3, 1, 4, -1, -2, and 3. Here we will have them 1. I'm going to write in different order. 1, 2, 3, and negative 1, right? This is what we have because the 3 is repeated and the 1s is repeated and the negative 1s is also repeated, right? So I just wrote it this way. Now we pair them and you will see the difference right now. So negative 3 goes with 3. All right, very good. One input, one output. 1 goes with 1. Very good. One input, one output. 4 goes with 2. Very good. Negative 1 goes with negative 1. Very good. Negative 2 goes with negative 1. That's the problem right there. That is the problem. And finally, 3 goes with 1. We have a serious problem right here. We have a serious problem right here. Because 2 different inputs cannot give me the same output. Do you visualize this? 2 different inputs cannot give me the same output. That is no bueno. So therefore, it's asking me to remove one of these pairs right here, to remove one of them so that it can be a function. In order for me to make this a function, I need to remove one of these pairs, either this pair or this pair, because I cannot repeat the input. I cannot repeat the input. I cannot repeat the input. Now, which of these two will you remove? Negative 2, 1, negative 2, negative 1, or negative 2, 3? Notice that the answers, you don't have both of them. You only have this pair right here, which is C. This is the only one that you are able to remove and therefore make this a function. Let's continue now with problem number 39. As you can see in this problem right here, we have a cone, right? We have a cone, which is a popcorn container, right? And they sell it in the movie theater in order for you to get your popcorn. Pretty interesting, right? Now we're trying to find out the volume, right? What's the volume of this cone, right? We need to find out the volume. Remember, these formulas are provided to you, but anyways, the volume of a cone is 1/3 pi r squared h. Pretty similar to the cylinder, remember? But instead of being the cone is 1/3, right? The cone is just 1/3, but it's exactly the formula for the cylinder. It's just that for the cone, it contains the 1/3 piece right here. All we have to do is to use this formula, plug in the values that we are given, and that's it. We'll find an answer. We just need to make sure that we round our answer to the nearest tenth, right? We need to round our answer to the nearest tenth. All right, so the volume of this cone will be 1/3 times pi times r squared. In this case, r, my radius is 3 square, and h, my height is 5 inches. So my volume will be, when you multiply all of this in the calculator, will be 47.1239, right? This is my volume. Now, since I am rounding this to the nearest tenth, we can argue that the volume of the cylinder will be 50 inches, remember? 50 cubic inches, because this is volume, right? Inches to the third. Whenever it's volume, it's to the third. Whenever it's area, it's to the second. Let's move on. Let's continue now with problem number 40. In problem number 40, it's a very interesting question because we have here a square shape, right? The area of a square shape of a garden. So let me do the square shape right here using this background that I have, which is really interesting. So I didn't do it perfectly, but you got the idea, right? This is my square shape. And we need to remember something important. In a square, right, in this figure, whenever we have a square, we know that the sides are all the same, right? This, and these are all equal. They are all the same. And I've been told that the area of the entire square is 324 square feet. Very good. I have the total area. Now I need to find what is the length in feet of each of these sides. The length in feet of each of the sides. So let's use the letter S, right, for a square. So if this is S, and I know that all are S, right, they know are the same, so therefore this is S. How can I find the area? Well, we know that the basic formula of the area is what? Length times width. Very good. So if I multiply this times this, I will get the area, right? Which is the same as saying, right? I can say then, I already have the area, right? I know the total area, and I know each of the sides. So I can say 324, I'm replacing A, remember, with the area that is given to me. 324 square feet, of course, equals S times S. I call it S because these sides are the same, right? The side are all the same. So it's S times S. And we can also rewrite this as 324 square feet times what? What is S times S? It's S squared. That's S squared, right? Now we need to solve this. In order for me to find the size, I need to solve this, right? So S squared is equal to 324 square feet. I need to find out what the value of S is. And there is a little trick that I always tell my students to remember. Opposite, right? Inverse operations. When we are squaring something, when something is a square, the opposite is a square root. Because there is an invisible 2 right here that will cancel with this exponent of 2. And therefore, I only have S now. S is equal to the square root of 324. We find this in our calculator and we realize that S is equal to 18 feet, right? 18 feet. This is the side, this is the length of each of the sides of this garden. Immediately, let's move on to our very interesting problem number 41. In this problem right here, we've been asked to find the line segment AB. Right? We need to find the length of this line segment. As you can see the question right here. What is the length in units of line segment AB? And there are different ways to do this. Right? There are different ways to do this. One of the ways that we can do this is using the distance formula. And the other way that we can do this is by simply using Pythagorean theorem, right? Using the Pythagorean theorem, which is also a very easy approach in my understanding. But I'll teach you both ways so that you can use whatever method you feel more comfortable with, right? So the distance formula establishes that D, right, the distance between 2 points, is equal to the square root, I hope it can fit right here, is equal to the square root of the coordinates of the points, right, pretty much. We can write the coordinates later, but let me show you the formula, the general formula first, which is x2 minus x1 squared plus, right, plus, guess what? Y2 minus y1 squared. And with this formula, I will be able to find the distance of point A and B, so the line segment, right, the length, with the distance formula, right? This is the distance formula that you can use. I'm so sorry, I thought you were looking at it, but this is the distance formula that you can use to find this side length. So let's write the coordinates real quick now. So we have here 2, right? My x value goes first. 2 comma negative 4 is exactly a negative 4, right? 2 comma negative 4. And the coordinates of my point B would be what? 7. It's exactly a 7. You go up, 7 comma 8. 7 comma 8. These are the coordinates of my second point B. All we have to do is to use the formula and we will be able to obtain our side length, right? That's one way for you to do it. So D is equal, first let's label them, right? Let's label them so to avoid any confusions. And I believe that's the smart approach to do, because if we label them, we will see that it becomes really easy for us to understand each of the points. So I'm going to label this x1, y1, and I will label this point right here on the bottom, x2, y2. And all I have to do is to replace them into our equation for the distance. So the distance will be the square root of x2, that is 2 minus x1, 7 squared, plus y2, which is negative 4, minus y1, which is 8 squared, of course. We plug in this in the calculator, and we have magic happening. We will have the square root of 169. The square root of 169. And immediately, once you are able to find this, all you have to do is to find the square root of 169, which is 13, right? Which is 13. So 13 units is the distance between point A and point B. Real quick, I want to explain to you now the other way that we can solve this by using the Pythagorean theorem method, right? Which is another formula for us to be able to find it. So first we need to complete this triangle, because this can form a triangle pretty much, by drawing a line from here to here, right? Forming a 90-degree angle right here in the corner. And I will be able to use the Pythagorean theorem formula. I will show you right now. So you see, I form a triangle. Remember, this is 90 right here, right? This is a 90-degree angle. And therefore, I can check the length from here to here, and I can use that length to use the formula. So from 8 to 0, that's 8 units. And then from 0 to 4, that's 4 units. I'm sorry, to negative 4, that's 4 units. So in total, the length of this side is 12. And then here, from 2 to 7, that's 5 units. Right? From 2 to 7, that's 5 units. So this measures 5, this measures 12, right? And then we're trying to find this right here. We can call this C, right? Let's call it C. We're trying to find C, the longest side. And one way that we can solve this is using, like I told you, the Pythagorean theorem, which is a nice formula that establishes the following. Right? Establishes the following. C squared, right? C squared is equal to the other two sides. Let's call this A and let's call this B. Is equal to A squared plus B squared. Right? How do I solve for C? Remember the little trick that I showed you here, that I showed you earlier? Whenever we have something in square, what is the opposite when you have something in square? You square root it, right? Do square root on both sides. So I do square root here, I do a square root here. This cancel, right? This cancel. In this case, it doesn't cancel because we're making an addition right here. So therefore, we obtain that C is equal to the square root of A squared plus B squared. And since I know what A is, which is 5, and I know what B is, which is 12, I just got to plug it in and I will be able to obtain C. So A will be 5 squared plus 12 squared. C will be equal to 25 plus 144. So C is equal to 169. Therefore, C is equal to 13. Both methods work, and they work very well. It is your choice to pick which of these methods you feel more comfortable with. Drawing the triangle, using the Pythagorean theorem, or just using the distance formula with the coordinates of the points. Let's move on. Problem 42 right now of this 2024 version, session 2 of the math test. Right here, we need to remember some concepts about parallel lines, transversal lines, right? And when the angles are the same. So as you can see, these lines right here are parallel, right? These lines right here are parallel to each other because they're going exactly in the same direction. They will never intersect, and they look completely flat, both of them. Now, these lines right here are transversal lines, right? These are transversal lines, and it's stated in the text, right? AD, AD right here, and AF right here are transversals, right? And then we can see that these two lines are parallel. P and Q are parallel to each other. Now, we're trying to find out what is the measuring degrees of angle BAC. Something very interesting to keep in mind. Whenever you have three letters like this, you're looking for the middle one. You're looking for angle A between these two rays. You start in the first letter, vertex, right? A, you go to B, and then you go to C. So this is the angle that we're looking for. This is the angle that we're looking for, right here in the middle, because that's what it's indicating to me. Angle measurement BAC, right? The angle A that is between B and C. This is the angle that we're looking for. Now, we know this is 110. This is given to us. Since this is a straight line and this is a transversal, right? I know that the entire angle from here to here must measure 180. If the whole thing must measure 180 and this is 110, therefore this right here must be 70. It must be 70. This must be 70 degrees because 70 plus 110 will give me 180. 70 plus 110 will give me 180. And we can do the same thing on the other side, right? We can do 105, right? 105, and we know the total is 180. But then we do 180 minus 105, and we will obtain 75. And we will obtain 75 degrees. Now that we have these angles, we need to remember something even more interesting. If this is 110 and this line Q, is parallel with line P, therefore if this is 110, this is also 110 right here. Angle B right here, this angle right here, is 110 as well. If this is 105, therefore this is also 105 right here, 105 degrees. And the same thing we can say for the internal angles, right? This is 70, this is also 70. This is 75, this is also 75. Now, as you can see, ABC is a triangle. This is forming a triangle. Let me zoom it in for you so you can see it even better, right? If I draw this triangle real quick right here, just the piece that we're looking for, right? If I do a little drawing right here, this is how this triangle will look like, correct? This is how this triangle will look like. This is B, this is A, and this is C. And we know this is 75, we know this is 70, and we're trying to find this. Any triangle, remember, the total will be 180 degrees. If I know the total is 180 and I already have two sides, I can simply do the following. 180 minus 70, right, minus 75. And when we do the math, we will obtain that this is equal to 35 degrees. And it makes sense because look, if you add all these three, you get 180. When you add all of them, you must get 180 degrees. Let's move on. We have more problems to go now. Problem 43. This is a very interesting question because this is the one that is asking you pretty much to understand and write down what you truly understand about the problem, right? So you have an equation here, y equals 1.5x plus 29. We already know this is what? The y-intercept. And we already know this is the slope. We already know this, right? By now you should. So, and then we know that this is used, right, to model yearly salary y, right? A yearly salary y. This equation is showing me the yearly salary of an employee in thousands of dollars, where X is the number of years. Okay, X, this is good information. X is the number of years the employee has worked for the company. And it's asking us, what does the slope of the line represent in this situation? This is a very, very interesting question. So we need to understand what the slope actually means, what this 1.5 means, because this is the slope right here, 1.5. Remember, my slope is 1.5. But what is the meaning of this number? What is the actual meaning of this number in this context? So this is the rate of change of the employee pretty much, right? This is the rate of change of the employee per year. And we know that the salary is measured in thousands of dollars. It's measured in thousands of dollars because it's said, it's established right here that the salary is measured in thousands of dollars. Therefore, our statement is clearly that each year, right? Each year, the employee's salary, sorry for my handwriting, the employee's salary, what happened to the salary? What do you think is happening? The employee's salary increases, how much? How much do you think it increases? Increases by $1,500. This is the clear, full statement. His salary is increasing by $1,500 per year, right? $1,500 per year. Or, well, we already established it right here, each year, right? The employee salary increases $1,500 per year, or $1,500 per year. All right, let's move on. Problem 44. We have here two different representations, right? We have a table and we have a graph. Right? We have a table, we have a graph. And the problem is about a dog owner, and he collected data for his two dogs, right? And he wants to find out which pretty much the difference, right? The difference he needs to find out, right? The owner needs to find out what is the difference in feet per second between the speed of the two dogs, right? We need to find the speed, the rate of change, the slope, the constant of proportionality. So how can we do that? How can I find out what is the slope for each dog, dog A and dog B? Because we have here showing some great information. And this point right here can be extremely useful. Let's write the coordinates real quick. Whenever you're given a point, write the coordinates. It's very useful to write the coordinates. 7, 200. We got the coordinates of this point. We notice that it starts at the origin. Very important. Very important. If it starts at the origin, in order for me to find the slope of this graph, all I have to do is to divide y over x, and I will get m, or as you may know it, COP, right? The constant of proportionality. So let's do this division real quick. Remember, first number is x, second number is y. It's already here, x and y. So we do 200 divided by 7. 200 divided by 7. I am so sorry, my apologies. This is not 7, this is 8. My apologies. So this is 8. So 200 divided by 8. Right? 200 divided by 8. My apologies for the mistake. So 200 divided by 8 will give me 25. This is 25. 200 divided by 8 is 25. So if I want to write the equation of this line, the equation for this particular situation, it would be y equals 25x. Right? This is the equation for this particular dog. Now here it's similar to a problem that we did previously, where we were dividing y over x for each. Right? We were dividing y over x for each to find out what the rate of change was. And that's exactly what we're going to do right now. 56 divided by 2 is equal to 28. 112 divided by 4 is also 28. 168 divided by 6 is also 28. And 224 divided by 8 is also 28. So we can see here what the slope for this particular dog is. And we can write our equation for the dog as well. It's going to be 28x. So now we can see the speed at which each of them is going. One is going at 28, right? At 28 feet per second, right? Remember, feet per second. And the other one is going at 25 feet per second. If I am asked to find the difference between these two dogs, all I have to do is to find the difference. 28 minus 25 will be equal to 3. Right? The difference in feet per second would be 3 feet per second, right? Between the speed of the two dogs. That is the answer for this question. 3 feet per second. Let's move on. We're almost finished. Problem 45. So in this particular problem, we are being asked to find what is the rate of change. We're given two order pairs, right, of a linear function, and they're shown below. And all we have to find is what is the rate of change. There is a beautiful formula to find the rate of change, or the slope. Remember, y, the difference in y over the difference in x, right? The difference in y over the difference in x, or pretty much the change in y over the change in x. We label our points, right? We label our points. So if you want, you can label it this way. It's up to you, but it doesn't really matter the order. I always label this x1, y1, and then the second one I always label it x2, y2 because it's the second point, right? But it doesn't really matter the order. This one can be x2, y2, and this one can be x1, y1. It doesn't really matter. So now that I have labeled my points, all I have to do is to plug it into my little formula, and I will be able to find the rate of change, because the rate of change is just another word for slope, for constant of proportionality, for unit rate. Therefore, let's use our formula. A slope will be equal to y2. What is y2? 5 1/4 minus y1, 4 1/2, divided by x2, which is 3, minus x1, which is 2. So when we do this little difference here on the top, we will obtain 1 1/4, 1 1/4, divided by 1, because 3 minus 2 is 1. And when we perform our division, we'll realize that our slope is 1 1/4. That is the rate of change. And that is our answer, right? Rate of change. Remember to show all your work because these questions are worth 2 credits, but you got to show your work. Let's move on to question 46. 46. And we're trying to solve this equation in this case, right? We're trying to solve what value of x makes the equation shown below truth. Right? We need to find out what value of x will make it truth. Pretty much that it will be equal on both sides. It will be balanced, right? What value of x will work? We need to use distributive property. We multiply right here and also distributive property on the right side, and we will have some fun solving this equation. So 1/4 times 3x will give me 3/4 of x minus 2, because 1/4 times -8 is gonna be 2. And then I just bring down the 4. Remember, don't distribute to the 4 because this is adding. Do not distribute to the 4. Do not distribute to the 4, only to the parentheses. And then here I'm gonna have 2x minus 8. And now we remember we need to do the inverse operation whenever we solve an equation, right? Inverse operation. So in this particular case right here, I am taking away 8. I will be adding 8 on both sides, right? I will be adding 8, but I can combine this entire thing because these are like terms. So I can combine it all, right? I can combine it all immediately. So 3/4x, right? And then this will give me 2, and 2 plus 8 will give me 10. So plus 10, and that is equal to 2x. And that is equal to 2x. Now I need to put the x together, right? I need to put these terms together. How do I do that? Well, I need to take away this. I need to take away 3/4x on both sides. So these cancel, right? These cancel. Remember, these cancel as well. And now I just bring down my value, which is 10. So 10 is equal to, we can put this in the calculator, remember? You don't put the numbers, the variables in the calculator, but you can put the numbers, right? You can do 2 minus 3/4, and the calculator will immediately process that computation for you easily. So we will obtain 5/4x. 5/4x. And therefore, in order for me to solve this, I need to pretty much get rid of this little fraction right here by dividing by this fraction, right, on both sides. I need to divide by this fraction on both sides so that I can get my answer and therefore finish and solve the problem. So 5 divided by 4, the same thing here, 5 divided by 4, and I will continue. Oops, I'm so sorry. I thought you were looking at it. So we divide both sides by 5/4, and then I'm going to continue here for the sake of space so that you can see the entire problem from the very beginning, right? So you can see the entire explanation. And then now what I have right here is that x will be equal to 10 times 4/5, which is equal to 8. Remember, you can use the calculator to solve this easily. Another option is to convert this fraction to decimals. That's another approach you can use, and it's going to make your life easier. So let me solve it right here differently so that you can see it. All right, I'm going to continue with the same problem, but I'm going to make it a decimal so that you can see it even better. So once we have our original equation, which is this one right here, this is our original equation. All we have to do is to take any fractions we haven't converted into decimals. So we know that 1/4 is 1/4, right? Because this is 1/4, this is 1/4. This is equivalent to 0.25. So 0.25 times 3x minus 8 plus 4 is equal to 2 times x minus 4. And then I use distributive property now, but I'm dealing with a decimal rather than a fraction. And that is easier, and you will obtain the exact same answer. So we use distributive property here, we use distributive property here, and we will obtain exactly the same answer. There's no difference doing it this way. So 0.25 times 3 will give me 0.75x minus 0.25 times 8, which is equal to 2, plus 4, I bring the 4 down, remember, just bring it down, equals to 2x minus 8. You see, the only difference is that instead of having a fraction, we have a decimal now. I can combine the like terms now. 0.75x plus 2, this will give me 2, is equal to 2x minus 8. Now what I do is I send this 0.75, I send it together with this x right here, right? 0.75x, I subtract here so that I can be together here. And then I bring down my 2. So 2 is equal to 1.25x minus 8. Then I add 8 on both sides. I add 8 on both sides. And I will obtain 10 is equal to 1.25x. And my final step is divide by 1.25 on both sides. And then 8 is equal to x, or x is equal to 8. So we obtain exactly the same answer. I hope this way it's better for you to understand. Let's go to problem 47 now. Problem 47. This is a very interesting problem because this is a topic that is about rational and irrational numbers, and we need to fully understand what is actually happening with each of these numbers, right? To fully understand what's going on. So the first one is a square root of 49. Is a square root of 49 rational or irrational? This is rational. How do I know it is rational? I'll tell you right now. It is rational because the square root of 49 will give me 7, right? And we know that 7 times 7 is 49, which is an integer, right? So this right here can be written as a whole number, or also can be written as a fraction, right? I can write this as a fraction. So the square root of 49 is 7. That's a whole number. Or I can write it as 7 over 1. So this is the reason why this first term is rational, right? This is rational. Now 1.3 repeating, right? When decimals are always repeating, right? Repeating decimals are always rational. Repeating decimals are always rational. So, and this also can be written as a fraction, right? This is one reason, right? The repeating decimals, right? Repeating, right? That's one reason. Repeating decimals are always rational, right? Repeating decimals are always rational. And besides that, we also know that we can express this as a fraction. And the fraction that I can use to explain, to represent this is 4 over 3. 4 over 3 is the fraction that I can use to represent 1.3 repeating. What about the square root of 32? The square root of 32. I strongly suggest you use the calculator when you're given these kind of values so that you can see what is the answer. So the square root of 32 will give me 5.656854, right? What do we notice here? What do we notice? We notice that the square root of 32 is not a perfect square. Remember the list of perfect squares, right? 4, 16, 25, 36, 49. These are all perfect squares, right? And all of these are perfect squares. So these are just a whole number. But 32 is not, right? The square root of 32 is not a perfect square. And the decimal goes forever without repeating. We see these decimals, they go on forever without repeating. And therefore, we cannot express this as a fraction. I cannot use a fraction to explain this, to represent this. Now, 7 over 2. What is 7 over 2? It is rational. This is a rational number. But why? Why can I classify this as a rational number? Because it's already in a fraction form of two integers, right? It's already 7 over 2. So this is already a rational number. Now, what about 1.2, 3, and 4? 1.2, 3, and 4. It has non-repeating but terminating decimal, right? None of them are repeating. You see, this is 2, this is 3, this is 4. And at the same time, it is terminating. So it ends at 4. It ends right there. And we can also express this as a fraction. Remember, we always try to express this as a fraction. So I can write this as 1,234 divided by 1,000. And that makes it a rational number because I can express it as a fraction. So this is your explanation for each of the problem. Remember to write it down here and use sentences so that way you can get the full credit. our last problem today, 48. All right, 48 is giving me one store information with a graph and another store information with an equation right here, right? This equation is representing the situation of a store A, and the graph is representing the situation with a store B. What is this problem asking me? The problem is asking me, what is the unit rate for the price of fabric per yard at each store, right? I need to find out how much each store will charge, right, per yard of fabric. And then later on, I will find out if I buy 9 yards, right? If I purchase 9 yards, what will be the difference, right? So it says store A than store B, right? How much more? How much more keyword right there? How much more? So we need to find the difference. How much store A will cost than store B. So let's get started immediately. So since I have my equation here for the store A, so this is store A, y equals 3.5x. I already know the price per yard is $3.50. It's $3.50. I notice that store B, it starts right here at the origin. If it starts at the origin, remember the little trick? We can do y over x to find the slope, to find m. So let's do it, right? Let's do it real quick. So we do 5.5 divided by 2, and we will obtain, right? I'm using this point, 5.5 divided by 2, and we will obtain $2.75 per fabric yard. So we already have the answer for the first question. So store A charges $3.50 per yard of fabric, and store B charges $2.75. I already have very valuable information that I can use. Now, if I buy 9 yards, this is the situation, right? If I buy 9 yards, how much more will that be? Well, all we have to do is to use this number of yards and replace it, right? So I already know that store A is represented by 3.5x, and I already know that store B is represented by 2.75x. So x is representing the number of yards. So all I have to do is to do some math. In this case, it will be 3.5 times 9, and in this case, it will be 2.75, I'm sorry, times 9. So what do we obtain when we multiply the store A yards, right? How much are we going to obtain? We do 3.5 times 9. That will cost me $31.50. That's the cost in store A. How much will it cost in store B? How much will it cost in store B is $24.75. That's a store B. Now, how much more will it cost, right? From one store to the other. So all we have to do is to find the difference, right? 31.50 minus 24.75. And the difference is $6.75. This is how much more it will cost in one store versus the other. Make sure that you subscribe, like, and share this video with other peers and other classmates so that everybody can learn and enjoy. If you have any questions, if you struggle with any of the questions, let me know in the comments below, and I will be able to reply back or take it into consideration for my next videos. Thank you so much for your support.